All right, so we said the answer for 1A was 2 ornaments per hour, right? The answer for 1B was 2.5 ornaments per hour, and the change in productivity was 25%, an increase of 25%. All right, question 2. Michael's janitorial cleans chemical tankers in the Bay Street, Upper St. Andrew area. The company typically cleans 70 tanks per month. They utilize 10 gallons of solvent, and 2 employees work 20 days per month, 8 hours a day. The company decided to switch to a larger cleaning machine. Last April, they cleaned 60 tank cars in only 15 days. They utilized 12 gallons of solvent, and the 2 employees worked 6 hours a day. What was their raw material and their labor productivity with the standard equipment? All right. Chris Thompson. Chris?
Good night, sir.
We're on to
okay, so sir.
We're on to question 2. And it's A. What was their raw material and labor productivity with the standard equipment?
Okay, so sir, I have for the labor, I did the labor productivity for both the old and the new. So for the old labor productivity, it was 0.22 labor hours. And for the new, it was 0.33 labor hours.
Right.
I didn't actually did the equipment. I did just the labor, sir. I just realized that you asked for both.
Yeah, it's in the problem. Raw material and labor productivity. All right, you didn't do it, so those 2 answers are correct. Donika, can you hear me? Donika Clark, what was your labor? What was your raw material productivity? Huh?
This is my first class, so I'm just trying to follow through.
Okay. Andel Blake, what was your raw material productivity?
Sir?
Yes.
I didn't do number 2, sir.
Which one did you do?
4 and 5. In the 2 and 3.
You skipped 2 and you did 4 and 5. All right. Janelle Gray. Janelle, are you there? That's Janelle Gray. Okay. This person who don't answer, I'm just gonna take them out of the class. That's the truth of the matter. We can't operate like this. All right. Carvalhy Ricketts. So that's Carvalhy Ricketts and Janelle Gray.
Sir, I did not do the question.
Which question did you do?
Well, I did question 1, but I didn't do the calculations.
You got the answers for question 1?
I didn't do question 2. So, but I'm trying to work it while I'm in class. So.
Okay. Kamisha?
Yes, sir.
Yeah, what do you get for your raw material?
For the first production, I have 7 solvents per tank. And for the second one, I have 5 solvent per tank.
Okay. That's your productivity. All right. What about your percentage change? Did you try that?
Yes, sir. I got a negative 28.57%.
Excellent. Excellent. All
Excuse
right.
me, sir.
Uh-huh.
Sir,
Mm-hmm.
I don't quite get that part.
Don't
The raw
quite.
material.
Well, it's raw material. It's the standard equipment and then the large machine. So for the standard, it's going to be 70. It tells you in the problem that it did 70, clean 70 tank cars, right? With 10 gallons. So it's output, right? So you clean 10 cars over your input, and the input you're talking about is the solvent that you use here, because it says raw material. The only raw material is the solvent. Are you seeing that?
So it is 70 divided by 10?
70 divided by 10, as simple as that.
Okay. Thank you.
And for the new on larger machine, it's going to be what? Tell me.
It is going to be 60 divided by 12.
Right. And so you get your 5, and now your percentage change, right, is going to be your new productivity minus your old productivity over your old productivity, which gives you a negative 28.57.
So you said new divided by old?
No, new productivity minus old productivity divided by old productivity, and you do that for percentage times 100, and that gives you your percentage.
Okay, thank you, sir.
There's a slide on that, there's an entire slide which I gave on that. P2 minus P1 over P1 times 100. Right? All right, so let's
Sir, is it okay if I use the other formula? Because that's the one that I used with the new productivity over the old one minus 1 times 100.
down. That's correct. That's the same. It's the same thing. It's just that you've divided the old productivity to get 1. Anyhow, it's okay. You can use the same one, not a problem. Use any other 2 formulas. So we didn't get the productivity for labor. Danielle?
Yes, sir. 50, I have 50%, sir.
Oh, yes, yeah, 50% is correct. All right, so it says, okay, so we've done all of them actually, in answering all of those questions. What is their raw material and labor productivity of the larger machine? So that's fine, so you did both. And what is the change in productivity? So that answers both of them, so that's easy enough. All right, let's move on to question 3. I'm assuming a lot of people didn't do this, but I'll be calling on persons because it's tutorial, and that's what tutorial is that you do the problems, and what you don't understand, you ask, and then yeah. All right, so Sue's Pottery spent $4,000 on a new kiln last year in the belief that it would cut energy usage by 20% over the old kiln. This kiln is an oven that turns greenware into finished pottery. Sue is concerned that the new kiln requires extra labor hours for its operation. Sue wants to check the energy savings of the new oven, right? And also to look over other measurements of their productivity to see if the change really was beneficial. Sue has the following data to work with. I hope you guys are looking at the problem, right? You should have it, even though I'm not showing this on my screen, am I? I don't think so. Yes or
You
no?
just need to scroll down a little bit, sir.
Right. Okay. Give me a second. All right. How's that? Better? Seeing it now?
No, sir.
No, sir. One more.
All right. Resume share. How's that now? That's better, right?
Sir, zoom it. You need to scroll down.
I'm gonna open it up. Hold on. Yep. All right. Okay, so Sue's Patry spent for, we read that already. She wants to check the energy savings of the new oven and also to look over other measurements of their productivity to see if the change really was beneficial. Sue has the following data to work with. The production, finished goods, 4,000 for last year, this year, 4,000. Same number of units, but greenware pounds was 5,000. This last year, this year was same 5,000. Labor hours was 350 last year. This year is 375 labor hours. Capital spent was 15,000 last year. Capital spent this year was 19,000, and the energy was 3,000 kilowatt per kilowatt hour. And this year it went down to 2,600 kilowatt hour. Were the modifications beneficial? Were the modifications beneficial? Anybody?
No, sir.
All right, let me show you how it would work this one.
So that's the answer I'm giving. No.
Huh?
But if the modifications were beneficial, my answer is no. It was not.
No, it was not. Okay. Why did you say that?
Because the energy modifications did not generate the expected energy saving. Also, the labor and capital productivity was decreased.
Okay. Anybody else? Anybody else? Anybody else tried it?
Sir, when
Go ahead.
So I was saying that when I did the total factor productivity for both from last year and this year, there was like a decrease in the productivity. So that's why I said it wasn't beneficial.
Good, good. And you did multi-factor productivity?
Yes, sir.
Okay. Everybody knows what multi-factor productivity is?
Yes, sir.
Yes, sir.
Okay. Okay. All right. Michael Metcalf, did you try it? What was your productivity, multi-factor productivity for last year, and what was it for this year? Metcalf?
Hello?
Michael, I can't hear you.
Okay, sure. No, I did not try it.
You didn't do the problem. Okay. Carry on, Ellis.
Good evening, sir. This is my first class and I'm trying to catch on.
Renee Booth. Renee?
Yes, sir.
Yeah, what was your multi-factor productivity?
I didn't do the question.
Oh, you didn't do it. Okay. Shanika. Shanika, can you open your mic? It's probably Shanika Smith. Shanika. All right, so I can't. Zanoa, did you try it, Zanoa?
No, I didn't.
You didn't. You didn't try any other problems? Huh?
No, sir.
Okay. But you saw where all the tutorials questions were on Moodle, right?
Yeah, I checked my Moodle today.
Oh, today. Oh, you didn't see it posted in the group that what the questions were for the tutorial? All right. Anyways, let's move on. All right. Let me see here. Where modifications beneficial? Let's see. All right, so this is how you would do it. This is how you construct the answer. The energy modifications did not generate the expected energy savings. Also, labor and capital productivity decreased, and this is how you work it. So basically, I just did it in a table format. You don't have to do it in a table format, right? The resource, which is your labor, your capital, and your energy, right? So in terms of last year, your productivity, labor productivity, was 11.43, and you get that by 4,000. Watch, 4,000. You guys seeing this cursor moving?
Yes, sir.
So your productivity is going to be your output, which is your finished product, which is 4,000, right? Divide by your labor, which is 350. There's your 350 right here. So you get 11.43 units per labor hour, right? Here, because it's labor hours, here is your denominator, your input. For this year now, it's going to be the same 4,000. This year 4,000, but now you're dividing by 375 labor hours, right? So now your productivity has decreased to 10.67. So what is your change? The change is negative 0.76, right? And your percentage change is going to be negative 6.7% change. So your change in productivity is 0.76. From last year to this year, you basically subtract, you basically do 11.4, P2 is 10.67 minus 11.43, and that's how you get your negative 0.76. Everybody see that? And then your percentage change now is just going to be P2, which is 10.67 over P1, which is 11.43 minus 1 times 100%. We have an actual one whole slide that gives you this formula, right? The percentage change. Anybody does not have that slide or has not seen that slide that I told everybody to take a screenshot of, except for the persons who weren't here in the last class. I showed you that slide. You can always show it again, right? Let me just quickly go back to it. Oh, I've gone on to the other slide. Productivity. Here we go. Here it is, right? I told everybody to take a screenshot of this. Are you guys seeing this? No?
Yes, sir.
Yes, sir.
Okay. So everybody has that from last week. So it's not like something new that everybody is seeing, right? It's just a matter of applying the principles here. See, change in productivity equals P2 minus P1, where P2 is the new productivity, P1 is the old productivity. Percentage change is just the present productivity over the old productivity minus 1 times 100. All right. So let's continue. So here we go, the capital. Let's do the capital now. Productivity per dollar spent, right? So here we go. It's 4,000 for last year. Same 4,000. Productivity is 4,000, but you spent your capital spent was 15,000. So it's just 4,000 over 15,000, which gives you 0.27 units per dollar spent, right? And here it's 4,000 again, same productivity over, but you spent 19,000, right? So your productivity in terms of capital is now 0.21 units per dollar spent. So now your change is now a negative 0.06, and your percent change is now 22.27, 22.2%, negative 22.2%. It's just going to be 0.21, which is your P2, divided by your P1, which is 0.27 minus 1 times 100. And that's how you get your 22.2. In terms of your energy now, right? Your energy, and it's going to be your units per kilowatt hour. Again, it's 4,000 output divided by 3,000 kilowatt hours. So it's going to be 1.33 units per kilowatt hour, right? And then 4,000 divided by 2006, which gives you 1.54 units per kilowatt hour. Again, it's the same thing, but this time it's going to be 1.54 minus 1.33. So you have a positive change in terms of output per kilowatt hours. So it's 0.21, right? And your percentage change is 15.4. So they expected, I think, a 25% change, and we only got 0.21. So you see how you could answer the question? Look at this. So Sue's Pottery spent $4,000 on a kiln last year in the belief that it would cut energy usage by 25% over the old kiln. So what happened was it only saved what was the savings? 25% over the new one. And the percentage change was only 15.4, right? Only 15.4, she had wanted 25%. So that's why we said the energy modification did not generate the expected energy savings. Also, labor and capital productivity decreased. All right.
Sorry, is there a reason why we didn't use the greenware one?
The greenware.
It's in the table.
Where?
Down. Greenware pounds.
Oh, that is input. So you could use that because you could use that input, but it's not relevant, right? So sometimes you're given red herrings basically, but it's not relevant. You didn't have to use it here.
Yes, sir, that's what happened because the question is just basically asking you for the change in labor productivity and the rest of them. So when I saw this, I went straight to the multi-factor. I got the first part of it correct, where it asked about the labor productivity and the change. But when I saw all of this information, then the multi-factor is what came to mind. So I actually worked that part of it. Okay. I still got the same answer where the productivity decreased, but as I said, that information wasn't relevant.
Yes, it wasn't. It's a red herring, so to speak. All right. All right, we're on to learning curves now. Okay, so the learning curve. By the way, did you see the answers on the paper for the learning curve? Just checking. Were the answers there?
No, sir.
Okay. On the tutorial? No? All right.
No, sir.
Okay.
Sir, the answers weren't there.
Huh?
Answers weren't there.
Right, that's what I thought. I looked back at it and saw the answers for the learning curve were there. By mistake, I had put them there. All right, so let's do it anyhow. The learning curve for a product, is 90%, right? First unit took 10 hours to complete. By the way, everybody comfortable with productivity?
Yes, sir.
Yes, sir.
Okay. The first unit took 10 hours to complete. The manufacturer.
Is there a record in there for the productivity lesson that was taught for those who came late?
No. All right. But you should not be coming late. That's the thing, eh? The learning curve for a product is 90%. The first unit took 10 hours to complete. The manufacturer wants to determine how many hours the fourth unit will take by using the logarithmic method. The coefficient B for the calculation is approximately, what's the coefficient? Negative
0.1.
Right.
Negative 0.1520.
Right. How did you get that? Log what over log what?
Log
Log
0.95 or log 2.
Exactly. And if everybody heard that?
Sir, could you repeat?
All right. They're asking what is the coefficient for the calculation? And we're saying it's negative. They ask for the coefficient B. It's negative 0.1520. And the way you get that is B is equal to log of the learning curve divided by log of 2. And we did that in the lecture last week. Let's just look back at it again.
Somebody is asking if you could let them into the class.
Yeah,
please.
well, you know, it's 7:45 now. You know, if I keep stopping to let everybody in. Shanika, I need to talk to Shanika. Shanika, are you there? Are you at
Yes, sir.
Why do you keep going in and out of the class? I mean,
Sir, I was trying to switch the devices, but the internet connection is slow.
All right. So somebody is asking how we get B from the learning curve, right? And I'll just show you quickly. See if I can show you quickly. Oh, I think I had closed off learning curve. Whoops. All right. Anyhow, B for the logarithmic method is log of the learning curve divided by log of 2. And we went through it in detail last week to make sure everybody understood how to do it. And we people plug stuff into their calculator. So we shouldn't have an issue except for the new persons coming in. Yes? Except for the
question.
Yes, go ahead.
So the question that you're just looking at, it says that for that calculation is approximately. So when it says approximately, you're not going to work it out to its full entirety to get the final.
No, they're asking for B. I'm just at B right now. I didn't even move any further.
Sir, it's B I'm referring to.
Yeah, so B, it asks you what is B. It asks you what is the coefficient B. That's all it asks you for. It just wants to know that you know to calculate B. That's all it's asking you for. What else did it ask you for?
Nothing else, sir, because I worked it out full, that's why.
What did you work out though?
The part where I passed the log part and I got 8.10 labor hours.
For what? I mean, I'm not following.
For question 4, sir.
All they ask you for what was the coefficient B, which is just the log of the learning curve divided by log of 2. And that's how you get B. That's all it asks.
Yes, sir. And I got that, which is negative 0.152.
Right.
Yes, sir.
Okay. Give me a second here, tutorial answer. All right, great. Back to it now. Okay, sure. All right, so that's all it asks for. The coefficient B for the calculation is approximately, and that's it. Don't ask it for anything else, right? So be careful how you overthink some of these questions. I know they're easy, but you know, don't overthink them. All right, it says we're at question 5 now. All right, it says the first unit of a product took 832 hours to build, right? Oh, are you seeing my screen? Did I move up?
Yes, sir, we're seeing.
All right. The first unit of a product took 832 hours to build. The learning curve is 75%. How long will it take to make the 10th unit? Use at least 3 decimals in the exponent if you use the logarithmic approach. Anybody got that? Anybody got this one?
Yes, sir.
All right. Hold on. Kamisha, did you work it?
Yes, sir. I got 320.32.
For the 10th unit. Anybody else would confirm that?
Yes, sir.
Okay, good. Michael, you got that? Michael, did you get that answer? Not hearing from him. All right, Renee.
No, sir. Are you hearing me, sir?
Yes, sir.
I'm hearing you now.
No.
What did you get for question 5?
I didn't finish working it out, but I don't think I would have gotten that.
Why? Michael, did you work it?
No, sir. Are you hearing me, sir?
Yeah, you didn't work it. Why? You didn't have it? You have a question?
No, sir.
All right. So here it is. What is this? Where does this come from? From 301 to 325 hours. Hold on.
Got 319.98, call it 320.
All right, the baby in the back row, is that Kenisha? Anybody got this answer? It's a little strange. Anybody?
Sir, I got 320, sir.
So I got
320, sir.
319 running up to 320, sir. That's the same thing.
Yeah, I don't know where that came from. All right, but we should probably just work it though. Learning curve, the formula for this one. Give me a second. Yeah, I have all of my SIPs thing up here. All right, give me a second here. SIPs. And we do have that table that shows us 75%, right? What B is for 75%. So for 75%, your B is what? Negative 0.415? Yes?
Yes, sir.
Yes, sir.
And so your T, they're asking you how long will it take to build the what? 10th unit?
Yes, sir.
Those who don't know, I'm just saying, so T of N. Let me just put it here so persons can see it. Stop share. All right, quickly, guys, for those of you who didn't try it, here it is. This is the question. This is the problem, or the solution to the problem. We're gonna be using logarithmic method, and T of N, right, is what we're trying to find, where N is now 10. You guys seeing the screen, right? Seeing this?
Yes.
Yes, sir.
Yes, sir.
N is now 10.
Yes, we are.
It's gonna be, and it tells you how long it took to build the first one, which is what, 800 and, because I'm not looking at it, 832, right? Times 10 to the power, and we said it was 75%, the learning curve rate, here it is, 75%. So your B here in this formula is going to be negative 0.415. So plug it in your calculator, everybody, and try to see if you get the answer, because I don't want you to wait until the exam or the test, and then you find that you have no clue to it. Please plug it in now. Let's move on. We're behind, but let's at least make sure everybody gets it. Plug it in your calculator, take the time, plug it into your calculator. So you're trying to find T of N, and where N is now 10. So it's going to be equal to the time it took to do the first unit, which was 823 times N, right? I would say N is 10 because they ask us how long it will take to do the 10th unit. So N is now 10, and your B you get from over here, your learning curve. Your learning curve value for B. And they tell you it's a 75% learning curve. So you find B over here, which is negative 0.415, right? So please, people, put in your calculator and work it so you know that your calculator can indeed work it. Can you quiet the baby, please? Please. I will, because we're recording, eh? All right. Amana, you got it? Amma, did you get it? Speak. I see your mic is open, so speak. Did you get it? Everybody needs to put these numbers in their calculator. Arlisa, did you get it? Carlessa?
I'm not quite sure, sir.
But plug the numbers in your calculator.
Yes, sir, I got 319.95.
Okay, that's good. All right, fine. Abigail, did you get it? Abigail, did you get it? Okay, not hearing.
Sir, I'm putting it in the calculator.
Yeah, I want everybody. I said that a while ago, so everybody should put the numbers in the calculator and try it. I guarantee you that some people is going to get it wrong because of not knowing how to use their calculator. And that's why I'm saying just put it in your calculator and work it. Chris, did you get it?
I get that arrow.
Exactly. So now you need to understand how your calculator works.
Yes, sir.
Figure it out. Danielle, did you get it?
Yes, I did, sir. I did when I wrote the question.
Get it long time. Andel? Andel, did you get it?
Yes, sir.
Oh, you got it. Okay. Kamisha, Allen?
Yes, sir, I got it.
Okay, good. Carrie Ann? Ellis Salmon?
Yes, sir, I got it.
Got it. Shanice? Shanice?
Yes, sir.
You got it?
Yes, sir.
All right, great. All right, well, I'm assuming that everybody would have gotten it, so fine. You know how to work your calculator. That's good. All right, so
sir, it's okay if you round up then.
Yeah, you can round up, but that's okay. So if it's multiple choice and it says to the nearest answer, then if you get 319 point something, then your nearest answer will be your 320 if that's one of the choices. You know what I mean? You guys are experts at doing multiple choice exams, right?
Okay.
All right, great. All right, so let's get to the other question. All right, 320. All right. If it took 1,000 hours to produce the first unit of a product and the learning curve is 70%, how long will it take to produce the 26th unit? To produce 26 units through to 50 units. Did anybody get this? Did anybody get this? Probably not, right?
Yes, sir.
What did you get?
3,903 hours.
Oh, you got it? Well, the answer was there, wasn't it?
No.
Oh, you got it? All right. You want to tell us how you got it? Tell us. Quickly. Time's going.
Sir, I got 186.76 for at time at 26.
No, but it says how long will it take to produce units 26 through to 50? So it asks, you know.
Sir, would you find the answer for 26 and the 50 and then add it?
No, not add it. So let's go.
Subtract.
Let's look at it this way. Let me write the numbers down so we can look at calculations. All right, so it's 1,000 hours. Right, learning curve is 70%. And it says they want to know 26 to 50 units. All right. So what you do, you find how long it takes to make to the 26th unit cumulatively, right? Remember that table now has unit and it has cumulative units. So see how long it takes to make up to 25 units. And then you see how long it takes to make the 50 units, and then you subtract one from the other, and that will give you 26 through to 50. Understand or no?
Sir, can you go over that again, please?
Watch, let's go to the table. I wrote the numbers down, so let's go to the table. Good question, so not a problem. Stop. Let's go to the table. Where are we at now? I'm gonna share a screen. Textbook up. Text, that's my problem. Text, let's see. I just showed the text a while ago. Oh, I closed it. All right, give me a second. All right. Oops, let's go to this table here. What is seeing this table? Seeing the table?
Yes, sir. Yes, sir.
Right, so it says, how long will it take to make from the 26th unit to the 50th unit, right? So you go to unit 25, right? And you look at your learning curve, which is now 70%, right? 70% learning curve. So you go to 25, it take 8. Your coefficient is 8.4, 8.404, right? So you can calculate how long it's going to take to make the 25th unit, right? So 25th unit is going to be T of n, and n is 25, is equal to T of 1, which is 1,000 hours. 1,000 hours times 8.404, right? That's how long it takes cumulative to make 25 units. You got that? Yes?
Yes, sir.
Up to 25 units, it's going to take that time, whatever that is. Calculate that. 1,000 times that is 8,404, right? Hours, right? To make 25 units, right?
Sir,
Yes,
can you
go
just
ahead.
go back a bit? Because I'm not following.
All right, so we're using this formula. And you were in class last week? Just check.
Yes, sir. Yes,
all right,
sir.
so we're going to use this formula.
Mm-hmm.
T of n is equal to T of 1 times C. And C is that, that constant. And we said, when we looked at the table, and we said this table is important. We spent a lot of time on this table last week, right? We were talking about C is the coefficient, where we said the number of units here, the learning curve percentage is here on top. Let me just go back over it. It's the percentage on top here. Yes, we said the learning curve is 70%. Go ahead, go ahead.
Why are we using 25 and not 26?
No, we're gonna get to that. So to make up to 25 units, you have the time for that. So now you're talking about making from 26 units to 50 units. So you know the cumulative time it takes, to make 25 units, right? So now you have to subtract the time it takes to make 25 units from the time it takes to make 50 units. That's why you're doing it that way and not looking at the 26. So you have to look at 25. And the other reason and the other way you could know this too, 26 is not even there as a coefficient. Look at it.
Yeah, that's what I was gonna ask. Why the table don't
Right,
just
so be smart. No, because the table would be very long. You know what I mean?
Yeah, I know it would be long,
Yeah.
but
Yeah, they just stopped it and started going at 5s, basically. Right? So then you look at look at 50 units, find the cumulative, how long it takes to make 50 units, right? So it's going to be 1,000 times 12.307, which gives you 12,307. And then you're going to subtract how long it took to make 25 units, which is 8,404. You subtract that, and that's where you get that answer. All right. Please make sure you understand. Right. You look at the time it takes to make 25 units. So you've made 25 units. Now you're talking about 26, 27, 28, 29 to 50 units. Right. So that's why it's that way. All right. Explain. I'm explaining it in its simplest form. Got it?
I think so, sir.
Sir, so what? So
they're saying they're asking, how long it will take to make 26 to 50 units. Right?
Oh,
You made 25 units. You know how long it took you to make 25 units. So now you subtract that from how long it will take it to make the 50 units, the cumulative number. All right, so that's how you get it. Okay?
Yes, sir.
All right, go ahead. That's a question or your comment?
Yeah, what I did was to use the logarithmic approach and find the 26, how long it would take to make the 26 and how long it would take to make the 50 and subtract both.
Now what you got?
Get 53.
No, you can't do it that way, no. You can't do it that way. You know why?
53.
Because that's the time it takes to make the 26 units, not the total time to make 26 units. You understand?
Oh, so you just...
Right, that's why this is the unit and one is this way. And again, good you brought it up because I emphasized it last week, but I'm not sure everybody. Boy. Kemisha, your mic, who's this? Kemisha or Amage, one of you mics was up with the music and all that. You guys to stop this, man. All right, so I'm going. This tells you how long it takes to make 7 units, the 7th unit, right? 7 units, 7th unit. And this tells you how long it takes to make all 7 units. 1, 2, 3, 4, 5, 6, 7. 7 units in total. So giving you the total time here to make 7 units, and this is giving you the time it takes to make the 7th unit. All right, so a big a difference there. All right. All right, let's look at.
Okay, it's fine.
Go ahead, speak quickly. Speak.
No, I wanted to know, how do we know which one of these things to use? The total.
Well, this table gives you a cumulative. There's no other table or no other method that gives you a cumulative. Think about it. This, let me go back down to here. All of the other ones are telling you how long it will take to make the nth unit. This is giving you both. This is giving you the nth unit here, and then it's giving you the total time for all units up to the nth unit. You understand? This table. Oh. Yeah, but good question. Very good question. Because if you had that question, I'm sure everybody else would have it. All right, so very good question. All right. Yeah, let us try and press on. Were there any more questions on that sheet? Were there any more questions on that one?
The answer for 6 would be 3,903.
3,903. Here it is. You can screenshot it, practice it back on your own. All right, there it is.
Yeah, I just wrote it out on my own.
Yep, good, very good. Okay, question 7. A small manufacturer that offers handcrafted furniture has developed a new style of desk that they believe will be very successful in the marketplace. It's expected that the first desk will take 60 hours, right? So the first desk, always write down that first production time, because you're always going to be using that back. Always, 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 right? So 60. So when you're doing the problem, just quickly write down T1 is equal to 60, right? 60 hours of craftsmanship time to complete. They expect a 90% learning curve, right? For the desk. How long will it take to make the 20th desk? Here we go. How long will it take to make the 20th desk? The firm is considering accepting an order for 25 desks. How many hours of labor will this require for all 25? So work that out, guys. I'm giving you maybe 5 minutes, because we need to get into the lecture and we haven't looked at the other productivity questions. I want you guys to practice this, because when the test comes, I don't want persons to say they've never seen this, or never done something like this. Work question 7, guys. I'm giving you 5 minutes and no more. You have the tables, right? Once you see anything that says all number, you know which table you have to use. All right, guys, I believe your 5 minutes is up. Carvali, are you there? Carvali and Handel, I had asked you guys questions before and no response. Is there any response from either of you?
Sir, I'm still working it out. So, sir, for the 20th desk, I got the 38.4 hours.
38.4 or 38.04?
0.04, sir.
Okay, and the 25th, all 25 units, how long would that take?
So that one is 1,062 hours, 0.78.
For the 25th. That'd be just 60 times 17 point, point
713, yeah.
713, right, which
What I got.
That's what I got, sir.
yeah, 1,062, 63, 1,063 hours, right? So that's all right. So we'll stop sharing and we're gonna move on now back to the question. Where we know screen share.
Sir, for the 20th desk, I got 38.1.
No, it's 38.04. 38.04. Here we go. Here are the answers. The answers are here, guys. 28 desk, 38.1 hours.
Sir.
38.04 though. So I guess I was using the wrong calculator at that time. And then the 25th unit would be 1,063 hours.
Sir.
Yes, go ahead.
What is the workout for the 20th desk, sir?
It's going to be 60. Your T1, you see where T1 is 60, right?
Yes, sir.
60 times 0.634. Want to see you saw we got 0.634?
No, sir, that's what I'm not seeing.
But I put the table up to show you, right? I put up the table a while ago.
Oh, I was looking at the wrong thing, sir. I looked at the 14.608. That's the wrong figure. Okay.
Yeah, that's for 20, that's for the 25, all 25 units.
Okay, sir.
14.9, and that would be for 20. For 25, let me go back at the table since we worked a while ago just to make sure everybody is
For 25, sir, it's 17.713.
17.713, right? But let's just look back at the table. Okay, you're gonna have to know to use that table. Where am I at? Stop share. Screen.
Something I must have done something wrong because we keep on to get the same 38.05.
Yeah, it's 38.04 I got.
No, 0.05.
Not a big deal. 38 point what?
38.05 for the 28th desk.
Yeah, I got 0.04, so that's okay. I mean, it's not a biggie. All right. I'm not showing you the table, right? Here's the table again, guys. So they ask you, how long will it take to make the 20th desk, right? Here, so you go to number you're looking for, 20. What is your learning curve? The learning curve is 90%. So you have to go all the way over to where 90% is. And you see that the 20th unit, how long it's going to take? This is unit just for N is 0.634. If they ask how long it will take to make all 20 units, you would use the 14.604, right? But they didn't ask you that. They say how long will it take to make the 20th unit? So you multiply, right? So I want to go through the table so you understand this thing properly. One is just the unit and one is all the units. 1, 2, 3, 4, 5, 6, up to 20, right? So one is cumulative and one is how long it take to make just that unit, the 20th unit, okay? Now the second one they ask is how long will it take to make all 25 units? So now you go to 25, number of units, 25, and you come across back to the 90 now, but now you're gonna use the cumulative. You guys are familiar with the word cumulative, right? Because I think I use that all the time, but it means all 25 units, right? 1, 2, 3, 4, 5, all the way up to 25. So you multiply your T1 by 17.713, and that should give you 1,063 hours. All right? Okay. Next, let's stop sharing that. And then we go into the other question. There's another question. Let's see. Share. Oh, forget about SWOT. I'm going to be doing that and multi-domestic. We won't touch, we'll touch this on, we'll hopefully get to this tonight, right? The multi-domestic international strategy and all of that. But I wanted to make sure we've done the calculations. Now, you were also to do question 1.1. Everybody saw that, right? Question 1.1, 1.2, 1.3, 1.4, 1.5, right? In the text. They are good questions to work, right? Good questions to work. For those who haven't worked it, I'm not going to do it tonight, but do it and we'll take it up next week because the other week is going to be your test, right? So let us try and get through globalization, the rest of it tonight. But continue with the problems in the text and we'll look at them. We have the answers, so I have the answers for them here. So we'll look at them next week. So let's proceed to the lecture on globalization. All right. Everybody clear on what I just said, right?
No, sir. Which question you said that we should look at in the textbook?
It's on Moodle, question 1.1 to 1.5.
Okay, sir.
All right. You didn't see it on Moodle? You didn't see me send out WhatsApp in the group? You didn't see all of that kind of stuff?
I saw the tutorial sheet 1, tutorial sheet 2 isn't coming up. That's all I was seeing.
No, but it tells you what to do. All right, so tutorial sheet 2 is telling you then question 1.1 to 1.5 of your text. Everybody clear on that? Did everybody hear that?
Yes, sir.
Okay.
Yes.
All right, so we're moving on the chat now. All right, let's move on to globalization, productivity. All right, I think I got to a lot of slides, but wow. Oh, we matched up all of that. No, we did that last class. Okay, mission. All right, so I think this is where we stopped. Developing missions and strategies, right? Mission statements tell the organization where it is going, right? Tells the organization where it's going. The mission statement will do that, or your mission. Whereas your strategy now tells you how you're gonna get there, right? Your strategy tells you how you're gonna get there. Your mission, right, tells the organization where it's going, but your strategy tells you how it's gonna get there. All right. Let me, right. So the mission basically, as I said, is where the organization is going. So it tells the organization purpose for being, it answers what the organization provides to society, and it provides boundaries and focus. Mission does that for you. Right, let's look at this company, Merck. The mission of Merck is to provide society with superior products and services, innovations and solutions that improve the quality of life and satisfy customer needs. To provide, and it says, it goes on, this mission, and it goes on to say, to provide employees with meaningful work and advancement opportunities and investors with a superior rate of return. So it looks at the stakeholders, what it's doing for its stakeholders, what products it's producing, the type of products, what it is all about. It's innovations and solutions that improve the quality of life and satisfy customer needs, right? So that's Merck. And then Hard Rock Cafe that, we looked at the last class. Their mission is to spread the spirit of rock and roll, so the music inside of the restaurant, right? By delivering an exceptional entertainment and dining experience, right? It says we are committed to being an important contributing member of our community and offering the Hard Rock family a fun, healthy, and nurturing work environment. So again, it tells you how it wants to treat its employees with a work environment, good working environment, while ensuring our long-term success. Right? So it details that. And there's a hospital one, and there's another couple of factors, another couple organizations, right? So factors affecting your mission. So here we go. Everything that must go into your mission is, you must think about your customers. As you saw, they did that. The environment in which they operate, right? Or the company operates, philosophy and values of the organization. And you want profitability. That's why you're in business most of the times, unless you're a non-profit organization, right? But you're mainly in business to make a profit and to grow. And you're concerned about your public image and your benefits to society. So all of this goes into your mission or your mission statement, all right? And here we go again with some sample missions. This is a company, it says to manufacture and serve and service an innovative, growing and profitable worldwide microwave communications business that exceeds our customer expectations, right? And the sample operations management mission now, right, which must feed into that, right, is because, operations maintenance is just part of that entire company, right? So to feed into that, the operations management mission would be to produce products consistent with the company's mission as the worldwide low-cost manufacturer, right? Because you're manufacturing, so they want, and operations is the one in charge of manufacturing, so they want it to be low-cost manufacturing. Here's another one with a O&M department mission, product design part, to design and produce products and services with outstanding quality and inherent customer value. So they want to create customer value in the products. And quality management, theirs is to attain exceptional value that is consistent with our company mission and marketing objectives by close attention to design, procurement, production, and field service operations. And there are a number of mission statements from the different departments within the companies, right? Here's one from human resources. Let me see if I can get back to the human resource one. Human resource. The human resource department says to provide good quality of work life with well-designed, safe, rewarding jobs, stable employment, and equitable pay in exchange for outstanding individual contribution from employees at all levels, okay? And there's more, but we'll skip past some of them because it's all the same. So the strategic process. So the organization's mission is at top, and then you have functional areas now. Remember the 3 functional areas I told you that you must know, because that comes on every test, right? The marketing, the operations, and the finance/accounting. So all of this, the organization mission must feed into the functional areas. So a strategy is the action plan to achieve the mission, as you said. How are you going to get there, right? How are you going to get there? And the functional areas will have their own strategies, right? And strategies exploit opportunities and strengths, neutralize threats, and avoid weaknesses. Remember, you saw the question about SWOT analysis, SWOT. We're going to get a little bit more into that. You guys have done SWOT analysis in other courses, right? Yes, no? Let me know, please.
Yes, sir. Yes, sir.
Okay, good.
Yes, sir.
Good. So you know what S means, W means, O and T, right? The SWOT analysis. Good. All right. So strategies for competitive advantage, differentiation of your product. So you're better at, or at least different from from the other products in the marketplace, right? That's product differentiation. You can be a cost leader where your product, for the same quality product, is the cheaper product. So people flock to your product. We said that, right? And response. Your response is you have rapid response to customer queries or any questions that customers might have regarding your product or your organization. So you need to know this, eh? Strategies for competitive advantage, there's three of them: product differentiation, cost leadership, and response. All right, very important that you know this. So competing on differentiation, the uniqueness can go beyond both the physical characteristics and service attributes to encompass everything that impacts the customer perception of value. Everything that differentiates you. So Walt Disney, the Magical Kingdom, it's their experience differentiation, right? The Hard Rock Cafe, their differentiation, they're saying it's a dining experience, right? Competing on costs, you need to provide the maximum value as perceived by customer, right? And it does not imply low quality. And that's why I said the lowest cost at a comparable quality of product. So just an example here, Walmart, they have small overhead, a shrinking or shrinkage distribution costs. So they're always reducing their distribution costs. That allows them to sell their products, the same products you'd get in a pharmacy or a supermarket or another store, but you'd get it cheaper at Walmart because they've reduced their overhead and reduced their distribution costs. So the same quality product is sold at a lower price at Walmart. All right. Competing on response. So now flexibility is matching market changes in design and innovation and volume. So it's a way of life at Hewlett-Packard. Some of you have Hewlett-Packard calculators. Reliability is meeting schedules. So any schedule at theirs, they'll meet it. And that's the machine industry, the German machine industry. Timeliness is quickness in design, production, and delivery. So it's not just time in terms of being able to respond to your customer, but you're responding to your customer in terms of the design and the production and delivery of the product. Like Pizza Hut, Motorola, and it gives you an example of Johnson's Electric. All right. So you're competing on response. So your response time is you respond very quickly. All right. So operations management contribution to strategy. Here we go. All right. So the operations decision, 10 of them, remember, is product, quality, process, location, layout, human resource, supply chain, inventory, scheduling, and maintenance. Here's the approach. Product differentiation, we have innovative designs, broad product line, after-sales service, right? An example, and it showed you the Safe Skin innovative gloves. They've come up with innovative gloves. Caterpillar heavy equipment service. Experience, Hard Rock Cafe, the dining experience, right? That is what gives them their product differentiation, right? Cost leadership, as we said, low overhead will give you that because you don't have to spend a lot of money on your overheads. So you can then sell the product at a lower cost, right? Inventory management, we talked about that. Walmart has a sophisticated distribution system. Response, when you're talking about response, you're talking about flexibility, reliability, and quickness. And we showed Pizza Hut, that kind of stuff. There's one pizza company I remember when I was in university. 30 minutes or it's free, right? Can you imagine that? If you order pizza and it comes, it takes longer than 30 minutes to get to you, you get it for free, right? And that was a big selling point of that piece of company. So remember the 10 strategic O&M decisions. I will ask you to remember them because there's so many other things to remember, but you need to know them, what they are. Okay, so operations decision, and we talk about goods and service design. The goods, the product is usually tangible for goods. And what we're doing is we're comparing the 10 O&M decisions, right, for goods, right here, and then we're doing it for services. So the goods and service design, the product is usually tangible, as you said, you can touch it, you can feel it, that kind of thing. Whereas for the service, the product is not tangible, right? Service is not tangible, it's a smile, it's how you talk to your customers, it's your, you know, that kind of thing. Whereas quality, it has many objective standards. So quality of standards, depending on what you're looking at, the weight, the height, you know, that kind of thing. The color, right? For goods, those are your standards. But for services, the quality is subjective. As we said earlier, somebody might answer the phone one way and pleases everybody else, but they don't please a particular section of persons who are not pleased with how the phone is answered. So it's subjective. Process and capacity design. For here, for the goods, the customers are not involved, right? Because it's more, we talk about goods, you know, talking about manufacturing for the most part. So the customers are not really involved, right? And for services, though, the customers may be directly involved, right? Because you're going out to see them. And capacity must match demand where service is concerned here, right? If somebody said they need 10 reps to come out, you have to send out 10 reps right away, right? For location selection, for the goods, you need to be near. And again, if you think about it and think about manufacturing, your manufacturing goods, your operations need to be near your raw materials, right? And labor. Whereas for services, you need to be near your customers, right? Because it's the customers you're servicing faster. For layout design, you're looking at production efficiency. And for services, you're looking to enhance product and production, right? Human resource and job design. For the goods, you need technical skills, consistent labor standards, output based on wages, right? For services, is interaction with customers, and your labor standards will vary. For supply chain, for goods, the relationship is critical to the final product. And for services, it's important, but may not be critical in terms of your supply chain, right? So your upstream supply chain, where you get certain things from, that might not be critical, right? Inventory, for the goods, raw materials, work in process, and finished goods may be held. For inventory, you can't really store service, really, right? And for scheduling, you have levels of scheduling that is possible. And for service, you need to meet immediate customer demands. As I said, if they need you out there, you need to get out in the field, all right? And for maintenance now, for goods is often preventative maintenance and takes place at the production site. For services is often for repairs, right? And takes place at the customer's site, okay? You guys follow that, right? Yes, no, I'm not hearing any questions, interaction.
We're listening, sir.
Okay. Wondering if I was on mute. All right, so managing global service operations now. So it requires a different perspective on your capacity planning, your location planning, your facilities design. Thompson, stop marking up the screen, please. Your facilities design and layout and your scheduling, right? have different perspectives on it for your global operations. So process design. So I'll show you this because this is going to pop up again and in more detail. So now you have the variety of products going high. So you have a high variety up top and a low variety of products down here. And here on your horizontal axis, you have, let me tell you, sorry for that. Sure. That's my axis. Right. Here we're looking at the volume, how much you're producing versus the variety of products, how many types of different products you're producing. So we're saying that you're moving from low to high in terms of the variety of products and from low to high in terms of the volume, the number of products that you're producing. All right, so we said job shop, basically, it's a variety, a high variety of products that you're producing, but you're producing a low quantity of them. And so you move from your job shop to your mass customization. But let's go through it. So that's the job shop, right? And then you move to your assembly line, right? Which is, for example, you're doing cars, appliances, TVs, fast food, that kind of thing. It's repetitive stuff, right? So it's assembly line. Product focus, it's a continuous process, right? The volume is also high, very high, but there's not a high variety of products. That's why it's down here. And we're talking about manufacturing of steel, beer, paper, bread, basic stuff, but you're making a lot of it, high quantities. But up here now, right, you're talking about mass customization, where you're customizing a variety of products, but you're also doing a large volume. So most companies, this is the ideal situation, mass customization, right? Mass customization. This is the ideal situation. Right. Oops. So we looked at this, great. All right, let's look at the operation strategy of two drug companies, right? So brand name drugs incorporated and generic drug corp. Here are their competitive advantage. Products, oh man. Product selection and design. The product differentiation here is heavy R&D investment, extensive labs, focus on development in a broad range of drug categories. This generic company, they have low R&D investment, right? So they don't, R&D mean research and development, okay? So they have low research and development. Their focus is on development of generic drugs. In terms of quality, major priorities for this company, right? The brand name company exceeds regulatory requirements, whereas the generic company meets regulatory requirements on a country by country basis. So it's not going out there to go exceed it by much. It just does enough to get by. And here is process, so you can read up on all of this, guys. It's in your text, the difference between one company and the next. In terms of process, product and modular process, long production runs, which is the brand name company, right? Specialized facility, build capacity ahead of demand, so they have they have excess capacity. So if it is that, say, a particular district wants a whole lot more, they have excess capacity and can deal with that. Whereas with the generic drug company, it's process focused, right? General processes, it's like a job shop also approach, short run production, focus on high utilization. Yeah, and you can, as I say, you can read through the rest of it in your text. All right, just look at this one quickly. Human resources for the brand name company hires the best nationwide search for the best persons. Here, very experienced top executives, right? But other persons are paid below the industry average. All right, let's see that. And we can go on with all 10 that we're looking at. All right, so we're on to issues in operation strategy, resources view, value chain analysis, Porter's 5 forces model, operating in a system with many external factors and constant change. These are some of the issues, right? And we'll probably get back to that. But you guys have seen this before, right? Product life cycle in another course? Yes, no?
Yes, sir. Marketing.
All right, great. So good. Most of you would be familiar with product life cycle. So the first stage is the introduction, right? And this is the best period to increase your market share. And here you have engineering, R&D and engineering is critical because that's when you're just introducing the product and you're doing a lot of research and development and all of that, right? So this is your sales line, right? So sales are going up, and in your growth phase, which is your steepest part of the curve, right? It's practical to change price and quality image, right? And strengthen your niche, because if you just introduce a product, then basically you're operating in a niche market, because a niche is a niche until you have other competition coming into the marketplace. You guys know that, right? Yes, no? Niche or niche, depending on how you want to pronounce it, tomato or tomato. Schedule or schedule, just depends how you want to pronounce it. And then here you have maturity, right? So it's a poor time to change your image or your price or your quality, right? Because you have a lot of competition in there. Competitive costs become critical, and you now need to defend your market position, right? And then you then goes into your last phase where you're on decline, right? And this is where you need to do your cost control. That's critical. Okay? You can't increase price, so you have to just control your cost, right? To try and maintain a certain margin or profit. All right. And they're giving you here like analog TV. Nobody buys an analog TV anymore. Everything is digital, right? So this product is on decline, or has been on decline, and will be kicked out. Because nobody makes those big back TVs anymore, right? All right, so that's your product life. And here, it's just telling you, you need attention to quality in your introduction phase, right? You have limited models because you just start making them. You have a high production cost because you have not come up your learning curve yet. You just start making them, right? You have short production runs because maybe your demand is not as high, so you're producing less. You have frequent product and process design changes. Because yes, your design persons and your engineers are still tweaking things to get to a certain point. So here now you have growth, which your forecasting is now critical because this is the sharpest part of your sales line, your growth line, right? Product and processes, reliability is important that you're reliable because no customers are using your product and demanding your product. So you want to be reliable. Competitive product and improvements and options, so you can improve the product in this phase, your growth phase. You need to increase your capacity because your demand is going up, because it's your demand line, right? And you shift towards a product focus, and you need to enhance your distribution, because if you can produce the product and your distribution is good, then you'll be fine. Maturity, basically you standardize your manufacturing process. You have fewer changes, right? And you kind of optimize your capacity. You're not gonna build out no big amount of capacity anymore, right? Increase stability of the process. You have longer production runs because you're cutting costs with longer production runs, right? You're not stopping and starting and doing changeovers. You're running longer times, so your production cost is being reduced. Product improvement and cost cutting. Yes, definitely in the mature, but in your decline stage, you have little product differentiation. There's so many people in the marketplace. Yeah, and you need to reduce your capacity. That first slide just said where I stopped on a Tuesday for another class. Okay, so SWOT analysis. Strategy development and implementation in SWOT. All right, so as you well know, as we said, so your analysis, your mission, you need to do your analysis and then you develop your strategy based on this, right? So when you're looking at strengths, you're looking at your internal strengths. It's important that you know what you're looking at, not your external factors, but your internal strength, your internal weaknesses, right? And for external, now you're looking at your external opportunities and your external threats. You guys went through this already, but I just want to emphasize it. What is internal and what is external. Make sure you know that. All right, guys. The strategy development process. So you analyze the environment, you identify the strengths, weaknesses, opportunities, and threats, right? You understand the environment, the customers, the industry, and the competitors. You need to determine the corporate mission, right? Once you've analyzed the environment, you can now determine the corporate mission. So you state the reason for the firm's existence and identify the values it wishes to create. Right? Remember, we talked about that earlier. You form a strategy. You now need to form a strategy. You build a competitive advantage. What's your competitive advantage? Remember, we've said there's 3 things for competitive advantage. Sorry. We said product differentiation. So that's going to come up all the time. Product differentiation, cost leadership in terms of your price, and your flexibility, how fast you can do things, right? So that's it. You form the strategy based on those three factors. So the key success factors, activities or factors that are key to achieving a competitive advantage. Those are your key success factors. Activities or factors that are key to achieving a competitive advantage. Your core competence, I need to know these here, guys. Your core competence, right, are the set of skills, talents, and capabilities in which a firm is strong. Okay, so that's your core competence. So you need to identify your key success factors, right? You need to build and staff the organization. And you need to integrate operations management with other activities. The operations manager's job is to implement an O&M strategy, provide competitive advantage, and increase productivity. Okay? Okay, we're good. And key success factors, and it tells you which chapter you can find all of these things. Remember, we talked about the 10 things that needs to be done. You need to look at product, quality, process, location, layout, and we're gonna get to most of these actually. But this just tells you what chapter you can find them in. Okay. But remember, we talked about the three key areas: marketing, finance and accounting, and production operations, your area, right?
Okay.
Sorry?
Yes, sir.
Okay. These are the 10, and this is the 3 areas. All right, main areas that will always be asked of you.
So, sir, why production operations so broad?
It's broad. It is. It's just the way it is. No, it's just the way it is, you know. It's just the way it is.
Sheesh.
In any company, guys, it's this big. And because it's the course we're doing, I mean, I'm sure these guys could try and embellish their areas. But for any company you're going to, you will see it, especially if it's a manufacturing company, it's going to be large. It is going to be large. All right.
Wow.
Just the way it is, guys. Just the way it is. But that's good for you because now you have more options in terms of jobs and where you and what jobs you can do. Better for you
Well,
guys. I've
it's
always
really
said that.
rare to find. To me, it's really rare to find jobs in POM, production and operation management.
Really?
Like, yeah.
No, because you can fit into any organization, you know, because every organization must deal with their product. They must deal with the quality of the product. They must deal with the process. They must want to know where to locate and all of that. And you can give advice on that. They want to know about layout, how you lay out. If it's a supermarket, how you lay out your products, you know. You put your meat at one side of the end, that kind of stuff. And we will get to that though. Human resources. You need staff to produce whatever you're producing. So you see, you deal with everything. Supply chain, you need to order stuff to get into your production line, your inputs, your outputs. Who's upstream of your plant? Who's downstream of your product? You know, inventory levels, economic order quantity, that kind of stuff. What's the best? Actually, as looking at a project and that came up, economic order quantity. You know, how big a capacity you need to build if the product is coming from far and this product is coming from Nigeria, Africa. The client wants me to tell them what's the economic order quantity based on the capacity they have. Do they need to build bigger capacity? Because they don't want chips coming in every day from Africa. Because Africa is far, the cost is gonna kill you.
Yeah.
So you know what I mean? So everything, to me, and maybe I'm biased, you can say I'm biased, but for me, everything is production and operations management. But I'm probably biased. Let me say this clearly.
Maybe because others would say everything is accounts and finance.
No, what are you financing if you don't have a product or a service? What are you financing? You know, remember in a bank, even if you're in a bank, your product is loans, you know, that kind of stuff. Your product is mortgages, you know, so I think in any business, production and operations management has a place. Every business, okay? Am I past your time now? So next week?
Right on time.
So
Right on time.
here's the thing with next week now. Next week, I want you guys to work those problems out, right? And you're not working them for me, you know, you're working them for yourself for the test. I want you to work those problems out, 1.1 to 1.5 in your text. We're gonna do them, and then we're gonna come back to this and finish up globalization, because that's gonna take up your test, which is in week 5, all right? So we're gonna put it off here and continue next week. For those of you who didn't understand the problems that we worked, they're still there. Go and work them out until you understand them. All right. For those persons who are new in the class, there's about 2 or 3 people. Please go through the tutorial, make sure you understand. You need to read chapter 1 also. All right. So good night, everybody, and enjoy the rest of your week.
Same to you, sir.
Same to you, sir.
Great.
Okay, good night, sir.
Okay, good night.